Hi and welcome to this video about scanning with AMSI, which is the Anti-Malware Scan Interface. So normally if you want to scan a file to see whether it's malicious or not, what do? Now Windows Explorer provides an interface where you can right-click a file and say, hey, let's scan this thing with whatever is installed on the machine, and typically that would be like Microsoft Defender. But what happens if you need something else? So in general, how do you do this thing in code? So let's talk about that in this video. So first, the Anti-Malware Scan Interface is an interface, literally, it's a COM interface behind the scenes actually, that can be implemented by AMSI providers. These providers should provide support for scanning files. Very simple, relatively speaking. These are registered in the system registry, and in fact technically could be more than one, and if you work with the COM API you can actually choose the provider you want, or just use all of them, see what they have to say for a particular file, for example, or some string. So you can register a number of providers that you want, but in a typical case you have just one provider registered, which is the one provided by the EDR or antivirus system on your system. And so technically, if you don't install anything specific, it's going to be Windows Defender. But if you have some other EDR system, such as from CrowdStrike or SentinelOne or whatever, they will typically provide their own provider. And so you can either choose explicitly or just use whatever default you get. So what I wanted to do in this video is to show you how to do that with the C API. How can we scan a file with whatever or whichever is registered on your system as a provider. So let's see what that requires us to do. Let's create a new project as usual. I'm using C++ and Visual Studio 2026, the Insider preview right now, the Insider view, but doesn't matter, it would work on any Visual Studio that you have. So let's call that AMSI demo something, put it in my usual YouTube code directory, and we can start writing the code. So as I mentioned, there are two APIs you can use. One of them is the simpler one, the C-based API. It is easier to use, but it is less flexible. It just allows you to use a single provider, typically the first one if there's more than one registered. So I'm going to use that in this demo, and perhaps in the next video, which I'll provide to members only, I will show how to use the more flexible COM API to do something similar with the extra flexibility we get in that case. So first we need to include something, and that include is very simple. It's called AMSI.h. This is the one providing the APIs from a C perspective, and also the COM interfaces and methods and all that. Whatever we need, we're going to get it here. So I want to have as a parameter the file that the user wants to actually scan. So I'm going to take that as a Unicode string. So I'm changing the main to a W main, because Unicode strings are the more natural way of working with Windows, more efficient, and in some cases, in fact, necessary. So the first thing we need to do is to open a handle to the file, see that that file actually exists or something, because the actual APIs don't really require a file name, but instead they want a buffer, such as a buffer in memory or a string, things like that. So you have to open files yourselves and provide them with the buffer. So I'm going to do that. The first parameter is going to be our file name coming from the command line. Then we need the access. In this case, the only thing that I need is a read access. That's good enough. Then we have a share mode. So let's go with the file share read. I'm happy to share this file with others that might want to read it at the same time. Security, we don't care because it's not really up to us. We're opening an existing file, which means that open existing must be the constant specified. Then there are a bunch of flags we're not interested in, and a template file, which is not also relevant in this case. So if this fails, what we get here is -1 defined as invalid handle value, which means that something's wrong with the file. Maybe the path is wrong, maybe it can't be open for read access, whatever that may be. There's no point in moving on, so I'm just going to return an error. I'm going to call a little function called error, and just go ahead and go with that. So here's what that error is going to look like. The error is going to get an error code, some kind of code, and we're going to go to the default of whatever get last error return, which is going to be probably the most the most common case when we call this little error function. I'm just going to say error and display the error. That's it. I'm not going to do any more than that, and we'll figure out if there's actually some kind of error. What does it actually mean later on if indeed we find such an error. So let's add stdio here so we can do a little printf here. So if we can't open the handle to the file, obviously something is wrong. And of course we have to make sure first that we have enough parameters. So if we don't, let's just add another little simple usage thing like AMSI demo and file. So the user knows what they need to do to get this thing working. Okay, so now we have a file open. What's next? Well, let's see if we can get an AMSI initialization here first. So the way it works, there's an opaque like pointer or handle called AMSI context. I need to first initialize AMSI, which is done using the function AMSI initialize. This is where typically it will look for providers, I would believe, and of course we can get some information about that while debugging. So there's an application name, which really just could be anything you want. Typically it's going to be the name of the executable. This is just for kind of nice purposes, or maybe there's some kind of enumeration we can do, but we just need to provide some string, and then we get back this context thing, and it returns an H result. So it's basically a COM API that is happening behind the scenes, just being wrapped in some C-style API for convenience. And so if this fails, again, there's nothing we can do. Let's just call error with this value here. And that's what we will do for all error handling in this little application. So once we have that, we also need to open a session. So there's a open session function, if I can type correctly, AMSI open session, that requires the context and gives us back another kind of handle, which is called AMSI session. So the idea here is that the session might have some other specific data which is just for that particular interaction with the provider. I can have multiple number of sessions open at the same time, and this is just part of the initialization behind the scenes. In this case, it will actually create probably some kind of instance on the COM side of things, but we don't need to know about these things. We can just go ahead and use the API, and this is what I'm going to do. So next, we actually want to call AMSI to scan something. So there's AMSI scan. As you can see, you can scan a buffer or a string. Now, obviously, we have a file here, so a string is really inappropriate. We want to scan a buffer. Maybe a string is more appropriate when you have something like a PowerShell command line or something like that that might have malicious stuff in it being encoded or whatever that may be. So maybe AMSI scan string would be more appropriate then, but we're going to scan a full-fledged file, so we need to call AmsiScanBuffer, and it returns an H result. Now AmsiScanBuffer requires the context. Well, obviously we have that. And we also need the session later, so we have that as well. But then you can see it requires the buffer and the length, which we haven't yet provided. So how are we going to provide the buffer and the length? We need to read the data of the file. We can do that in two ways. One of the ways is to actually allocate a buffer, read the data into it, and pass it. The other option, which I like more, is about using file mapping. So I'm going to create a file mapping and then just map the memory of that file, well, the file itself, the contents of that file into memory. Just like we're doing with memory files in general. Please, if you're not familiar or forgot a little bit about that, I have a video on that as well that I did a couple of years ago or so. Okay, so create file mapping. The first thing we need is the file itself. And we need some attributes, which is going to be a page read only. I'm going to map that to reach only. Before that, we have security attributes we don't care about. So that's the protection, the read only, and then the maximum size. There's no maximum size because it's coming from a file, and there's no need for a name for this object because, well, we're not going to share that with other processes. If this fails for whatever reason, let's just bail out. It shouldn't really fail unless we're completely like out of memory. So now that we have that, we need to perform the actual mapping using the function map your file. That's actually mapping the the file contents into the address space of the current process. We have to do that. So we have hmap here. The access is file map read. That's all we need. And we're going to start with the start of the file, and 0 means all the way to the end of the file. So if that doesn't work for some reason, again, we probably are out of memory. Let's just call error here and be done with it. Once this works, we can make some forward progress. So we can pass the buffer here, that's good, but we're still missing the length or the size of the file in this case. So we'll get that momentarily. In fact, we can do that immediately here. We can use the function getFileSize to get the size of the file while we have a handle open to it. Here goes. It's not going to be a big one. I'm going to assume here the file is less than 4 gigabytes, which for PEs is always the case, so it shouldn't be a problem for PEs, which are probably the ones I'm going to scan for malicious thingies. But of course, they could be different things, like maybe a Word file, things like that. And just to go back for a moment to this example, if I have a Word file here and I right click, you can see I have the option scan with Microsoft Defender. And it's going to tell me that this Word file hopefully is not malicious. You can see there are 40 files scanned within because new, or I would say not so new at this point, all the docx, pptx and all those newer Office extensions are really zip files behind the scenes. There's actually different files within that executable or that zip, in fact, so they're being opened by a Defender there in terms of scanning. And so I'm going to assume here that the files are less than 4 gigabytes. If they're not, then we'll have to do something else. But in fact, technically speaking, this API is limited to 4 gigabytes as far as we can tell, because it accepts a ulong, that's a 32-bit unsigned value. So even if the file is bigger than that, we can't scan it, at least not in one go, which may or may not be good enough, but that's unlikely to be an issue. Typically, malicious files are not beyond 4 gigabytes, they're not really that big anyway. So that should be fine. And then we can provide a content name. This could be just anything, like some kind of string. We're just going to pass the file name. Seems like a reasonable thing to do. Then we need to provide the session, and the result is an AMSI result. So an AMSI result is the result of the scan. So I'm going to pass that in. So of course, as before, if there's some fundamental error in the call, there's nothing we can do, and just return shouldn't really happen. Well, not return, let's just return error with HR. Otherwise, we have the result. So if you look at AMSI result, what is that actually? It's actually a macro, sorry, an enumeration that provides a bunch of values. And you can see there's clean, there's not detected, which is probably the ones that say this is okay, there's nothing malicious there. And then there's other things here that represent maliciousness, especially the last one, result detected. You might notice there's a little macro here, which is also documented, that says really this is how to actually get a boolean whether there's a malicious thing here or not, just by looking at the value. If it's greater than or equal to detected, that's the thing. And so technically we can take this macro, and of course this is all documented, and you can say as the final result malware detected. I'm going to just say based on this kind of thing, it gets the result as a parameter, and if it returns true, that's a yes, otherwise that's a no. And basically we're done. We should probably perform all the cleanup there, like close handles, close the sessions, all that. I'm going to skip that to save some time. And let's give it a little shot. So the first thing we notice that if we try to compile this, it doesn't compile. It does compile, but doesn't link, because it requires these extra functions. It requires their import library. And fortunately, this is provided, so not a big deal. It's all documented. The library is called amsi.lib. As simple as that. Let's build it again. Now it works fine. Let's give it a shot first by using the debugger. So I'm going to go and choose debugging here, and let's pass it something like Windows. Let's go with regedit.exe. which is of course unlikely to be malicious, but let's try. Who knows? I mean, maybe we'll get surprised. Anyway, we can run this. Let's see what happens by looking at the list of modules. So right now, before we actually started, we see already many modules loaded, which is a very typical case. However, these are all normal Microsoft modules, not really very interesting in general. Let's move on to create file. Create file will not cause any new modules to load, and we get a good handle, which means this is a good path and all that is fine. We move forward to AMSI initialize. And now notice, we should notice perhaps new DLLs loading. Right now we have 10 DLLs in the process, and they're currently ordered by load order, which is convenient. Once I do that, you'll notice that many more DLLs get loaded. In fact, now we have 27 DLLs in the process. We had just 10 previously, which means this initialization caused something to load. We can try to kind of look at the list of DLLs, see if there's something that pops out, something that seems off or at least different. And it's pretty easy to see based on the path that all these DLLs are coming from System32. That's the normal Microsoft DLLs, but there's another one here that is coming from something else, different kind of location. So it is a good assumption that this probably is the one that's actually implementing that functionality. So we can open the file location of that. And you can see that it is somewhere here within the program data Microsoft Defender platform with some version. So if you have a different EDR on your system, if you do the same thing, you'll find that a different module is loaded here, and you can again go to where it actually is located, and you find that this has to do something with the provider, which is typically your antivirus or EDR that is on your system. By the way, if you don't see the modules window, you can go to debug Windows and then just find the modules here, and it will show up. You can see it's right here, and then you can drag it to a location of your choice. So let's continue just to complete this exercise. So we can just go ahead and do open session. This also works. Then we create a file mapping. We have a good handle for that. We're mapping the file into memory, into this buffer address. So here we have now an address, and then we finally can call AmsiScanBuffer. We can see that the result is SOK here, which means that the call succeeded, and the actual result is not detected, so there's no malware there. And if we go over to doing the printf itself, you can see it says that this is not malware, which is, well, I would say that this is good to know. It would be a malware that would be very distraught, distraughting, I would say, very like scary even. So let's go ahead and try this on something else. So I have here this AMSI demo. That's the file that we have. We can just pass anything we want to it. For example, let's pass something like kernel base, well, it's not there, so error number 2 is file not found, which makes sense. You can see this is not malware. However, I also have here something which is or might register itself as a malware. Under I have this mimidrv. So for those that are familiar, I think that Defender already already removed that. Let me just make sure it's still here. Yes, it is here. So mimidrv is here, just not under C, my bad, under D. So mimidrv is the driver for Mimikatz, for those that are familiar with this tool. And now it has a driver, so the driver might be differently detected. And indeed, Defender says this is malicious. So it decides that whatever that driver has in its binary from a static analysis perspective, it's not running that, it's not loading it or anything like that, it's just analyzing its static properties, that is as a PE, whatever it's importing and other stuff. We don't know exactly what they're doing there, but they're trying to figure out whether this is a malicious file or not, and apparently it is. So that's the basic way you can call AMSI. It's fairly straightforward, so you can add that to any application that you might have. For example, if you are a developer and want to add that kind of functionality into an application, you can just go ahead and do that. It's pretty simple to do. Like I said, hopefully in the next video I'll show how to go a bit beyond that into the COM interface and see where all these things are registered in the registry, and do some other perhaps more interesting stuff with what we can do with this interface. In any case, this is all documented, so I'm not making things up or kind of reversing like crazy code or anything like that. This is mostly documented, just a matter of trying things out and see how they work out. Hope to enjoy that. I'll see you in the next video.